John von Neumann received his early education in Budapest under the tutelage of M. Fichet, with whom he published his first paper at the age of 18. He was also a pioneer of the application of operator theory to quantum mechanics in the development of functional analysis. Von Neumann's assessments were the fact that he worked out of his key steps in the nuclear physics involvement in thermonuclear reaction and the hydrogen bomb. He also wrote 150 published papers in his life, 60 in pure mathematics, 20 in physics, and 60 in applied mathematics. His last work, published in book form, was The Computer and the Brain, which gives an indication of the direction of his interest at the time of his death. Von Neumann's interest in computer differed from that of his peers by quickly perceiving the application of computers to apply mathematics for specific problems rather than their mere application to the development of tables. During the war, von Neumann's expertise in hydrodynamics, ballistics, meteorology, game theory, and statistics was put to a good use in several projects. This work led him to consider the use of mechanical devices for computation, and although the stories about von Neumann imply that his first computer encounter was with the ENIAC, in fact it was with Howard Aiken's Harvard Mark I, also known as ASCC calculator. Post-war, von Neumann concentrated on the development of the Institute of Advanced Studies Computers and its copies around the world. While working with the Alamo Group, he continued to develop the synergism between computers' capabilities and the needs for computational solutions to nuclear problems related to the hydrogen bomb. Von Neumann was the first rigorously established as mathematical framework for quantum mechanics, known as the Dirac-von Neumann axioms, with his 1932 work Mathematical Foundations of Quantum Mechanics. Von Neumann's principal contribution to the atomic bomb itself was in concept and design of the explosive lenses needed to compress the plutonium core of the Trinity test device. Von Neumann oversaw computations related to the expected size of the bomb blasts, estimated death tolls, and the distance above the ground at which the bomb should be detonated for optimum shock wave propagation, and thus maximum effect. An outstanding creative mathematician, John von Neumann played a rather important role in post-war economic theory. One of his favorite quotes, "If people do not believe that mathematics is simple, it is only because they do not realize how complicated life is."